Hey everyone! Thank you so much for joining us for the next episode of our Spotlight on GitHub Advanced Security series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Ankit, thank you so much for joining us.
Thank you. Hello, everyone. Thanks for joining today. Every time you ship a project, you're not just shipping your code, you are shipping every dependency your code relies on, and each of these dependencies carries its own security risk. At GitHub, we help you secure that entire supply chain, from understanding what dependencies you have to surfacing the vulnerabilities hiding in them to actually fixing those vulnerabilities before they become a problem. I am Ankit Kumar Honey, Senior Engineering Manager at GitHub, where I lead the Dependabot team within our supply chain security organization. Here, what we will cover today. First, I will walk you through basics of what is dependencies, vulnerabilities to how Dependabot helps you secure your software supply chain. Then I will show you a brand new capability, assigning Dependabot alerts directly to AI coding agent like Copilot, Claude, Codex, and watching them generate fixes for you. We will do a live demo so you can see this end to end. Let's get into it. Here, what we will cover in our time together. First, I want to set the stage with basics about what is dependency vulnerability for our beginner viewers. Then we will understand what is the alert backlog problem, why security alerts pile up, and why that's a real risk. Then I will walk through how AI agent assignment work, the mechanics of assigning a Dependabot alert to AI coding agent, whether it be Copilot, Claude, or Codex. We will spend a bulk of our time on a live demo. You will see this end to end from alert to merged fits. Then I will cover the decision framework. When should you use AI agent versus Dependabot built-in security update? And in the end, we'll wrap it up with Q&A. I want to hear your questions as well. We are going to talk about something that affects every modern software team, dependency vulnerabilities. We will break this down step by step, starting with the basics of what dependencies are, what make them vulnerable, and how GitHub's Dependabot help us catch and fix these problems before they cause real damage. Whether you are a developer or not, by the end of this talk, you will have a clear picture of what is happening behind the scene to keep software safe. Let me start with a simple analogy. Imagine you are building a house. You do not make your own bricks, forge your own nails, or manufacture your own plumbing. You buy those from suppliers. Software works exactly the same way. When developers build an app, they pull in pieces of code that other developers have already built, a login system, a date formatter, etc. These ready-made pieces are called dependencies. A typical app might use 100 or even thousands of them. It is completely normal that it saves massive amount of time. So here is the catch. Because your app relies on the code that someone else wrote, you are also relying on the code that being secure. And sometimes security researchers or hackers discover a flaw in one of these pieces. That flaw is what we call vulnerability. Before the flaw is found, everything seems fine. Your app works, your users are happy, and no one notices the hidden problem. But the moment that flaws get reported publicly, every single app using that dependency is exposed. Attackers now know exactly where the weak spot is, and they can try to exploit it across thousands of apps at once. Let me give you a sense of a scale here. A typical modern web application uses over 500 plus dependencies. And again, these numbers are taken from internet, so it can vary. The numbers of new security advisories published each year is approximately 30,000 K plus. And even when a patch is available, many teams take days or weeks to actually apply it. No human can manually track all of this. You cannot sit down every morning checking 500 libraries against 30,000 advisories, figuring out which one affects you, and then go fix them all by hand. This is where Dependabot comes in. Dependabot is a tool built into GitHub that acts as your automated security watchdog. It runs in the background, constantly checking your project's dependencies against GitHub's advisory database, which is one of the largest and most active maintained database of known software vulnerabilities. When Dependabot finds a match, it does two things. First, it raises an alert in the security and quality tab for your repository. This alert tells you what the problem is, how severe it is, and which versions are affected. Second, for many vulnerabilities, it automatically opens a pull request that upgrades the affected dependency to the nearest safe version. All you have to do is review and merge. Here is the flow from the start to finish, which I explained in the previous slide. I'll just quickly go through it. It begins when a security advisory gets published, usually by a researcher or a maintainer who discovers a flaw. There's a service called Dependency Graph, which sits in between advisory database and Dependabot, which basically scans the repo and provide the information of like which dependencies are vulnerable. And Dependabot take those information, raises an alert, and in the end, if Dependabot security update feature is enabled, it will create a security update a pull request which users can uh, look into it, merge it, and that will fix that particular vulnerability. So for many alerts, this entire process takes less than a minute of your time. What you see as a developer, this is exactly what our Dependabot alerts look like. A notification appears in your security and quality tab. Then alerts tells you about what the name of the package where the vulnerability exists, what's the affected version, what the patch version it is, and this comes from advisory database. Then this alert tells you about the severity, whether it is high, medium, or low, and then it has bunch of other information, for example, EPSS score, etc. Dependbot opens a pull request if your security update is enabled in your repository or in the org, and it opens a pull request. You can look into the pull request. It's pumping a version from one version, like from the current version to the fixed version, and once you merge this PR, your alert goes away. What is the alert backlog problem? Let me paint the picture of the problem we are solving. The average application today contains approximately 581 open source vulnerabilities. That's 107% increase in just 1 year. And the mean time to remediate is 72 days. So what happens in practice? Dependbot generates alerts, developers sees them, but they are busy shipping features. The alerts pile up, the backlog grows, and that backlog isn't just a to-do list, it's an expanding attack surface. This is the alert fatigue problem. Detection without action is just noise, and that's exactly the gap we are closing today. But you can also question that Dependbot already generates PR to solve Dependbot alerts, then why there is an alert fatigue problem? And that's a very valid question. To answer that, not all alerts are created equal. Let me walk through the spectrum. The easy ones, simple version bumps. Dependbot already handles. It opens a PR, your CI runs, all the test passes, you merge, done. For many alerts, that's all you need. But when you hit the hard cases, for example, a major version upgrade that introduces breaking changes, your build fails, test breaks, someone has to go in, understand the changes and fix the code, or even worse, a compromised package like LLM attack in March 2026. The dependency has malware, there's no patched version, you need to downgrade to the last safest version and potentially rewrite the code that depends on the new API. Or even the another problem where you have a complex dependency trees where there is a conflict in the transitive dependencies and Dependabot security update is not able to solve it. These hard cases are exactly where the alerts piles up, and this is exactly where AI coding agents comes in. So Dependbot team developed a feature to assign Dependbot alerts to AI coding agent to solve the hard cases explained in the previous slide. Let me walk you through the complete flow. It starts the same way an advisory get published. The dependency graph scans your repository, Dependbot raises an alert. This is the flow you already know. And as we saw earlier from the simple version bumps, the Dependbot automatically opens a PR, you review it, merge it, and you are done. That hasn't changed. But here's what is getting interesting. After the alert is raised, you now have a second path. For the cases where Dependabot's auto PR isn't, security update PR isn't enough, breaking API changes, a compromised package that needs a downgrade, complex dependency trees, you can now assign the alerts directly to AI coding agent, for example, Copilot, Codex, or Claude. When you do that, three things happens. First, the agent analyzes both the advisory and your actual code base. It understands how your code uses the dependency, your patterns, your test suite, and your specific version constraint. Second, it opens a draft pull request with a proposed fix. Not just a version bump, but a real code changes. If the update introduces breaking changes, it's even attempt to resolve test failures it may have introduced. Third, and I want to emphasize on this, human review. AI agents always create a draft PR. AI generated fixes are not always correct. They can miss edge cases, produce incomplete patches, or introduce new issues. You verify test passes, confirm the fixes is appropriate, and merge when you are ready. This is the screenshot of assigning Dependbot alert directly to an AI coding agent. From the Dependbot alert page, uh, you have an option on the right hand side assigning to an agent where you can select the agent. You can select the type of the agent, and then you can select which model you want, and then it will go ahead and create a session for it, and it will start working. Later in the demo, we can see in the session what agents exactly are doing once the alert is assigned to it. All right, let's see this in action. I'm going to switch to my screen now, and I'll be presenting a live demo showing some use cases how to assign alerts to a dependent alert to an AI agent. Okay, this is the first repository. It has two simple scenarios. First, I will go and describe a setup. This is basically a Python app that routes an LLM request through Light LLM and fetches external resources via request. Both packages have known vulnerabilities in the pinned version. I'm using two packages here. One is request, which has a vulnerability, and the ID is CVE 20233261, and the second one is Light LLM. It has this particular CVE 20246587 vulnerability, and this is the CVE ID for it. Now, CI runs on every PR, including Dependbot security update PR. You can also see exactly what passes and what breaks before merging. I have two scenarios here. Scenario A, where a Dependbot security update PR is enough. What it will do is like it will just pump the request version from 2.28 to 2.31. CI run passes and merge the PR. We don't need to assign an AI agent to it. It will be an overkill. The second scenario would be where the AI agent will be required. Now, this is where the Light LLM attack happened. So Light LLM package, what it does is like, it has a severity and it needs to be updated from the current version to 1.40.0. Now, in this case, the CI will fail. Why? Because Light LLM will require Pydantic V2, but the app uses Pydantic version V1 syntax that was removed in V2. So Dependbot cannot bump this version. It cannot fix the code. The PR is stuck, and we need to assign this particular alert to AI coding agent and see what it does. So let's quickly get into it. Scenario one. I will take this CVE. You can find the alert in security and quality tab. Under security and quality, you have Dependbot findings. Under Dependbot, we have malware and vulnerabilities. Currently, malware doesn't have any alerts right now. So we'll go to vulnerabilities. Earlier, this was called as a Dependbot alerts. Now the name has changed. We are using it as vulnerabilities. Inside vulnerabilities, we'll have Dependbot alerts. I'll quickly go and find the alert which is impacting. So this is the Dependbot alert. It shows that the package request is having a vulnerability. This is the affected version, and this is the patch version. What I'm going to do is I will just go ahead and create a security update PR here. It will take a couple of moments to create a security update PR. In the meantime, what I'm going to do is I will go back, and we can just start with the scenario 2, scenario B. Now scenario B is where we need an AI coding agent. But what I'm going to do first, I'm going to create a security update PR, Dependabot security update PR, and see the CI breaks. I will open a new tab for the scenario B. I will again go to vulnerabilities. Yeah, this is the Dependabot alert, and this has the package is light LLM. The affected version is 1.44.8, and the patch version is 1.44. Affected version is less than 1.44.8, and the patch version is 1.44.8. So I'm going to go ahead and create security update. I have checked this like in the preparation of the demo that the CI will fail for it. So not to waste time, what I'm going to do is at the same time I'll assign this alert to a AI coding agent. So what I'm going to do is I'll click assign to agent. Now at this place, what happens is as soon as you're assigning an agent to an alert, the original prompt is the Dependabot alert. It takes the entire alert content as in context. This is basically what the repo is. This is the branch, and then you can select like which agent you want. We have Copilot, Claude, and Codex. I'll use Claude. Sorry. And then you can select like auto, or you can specify which specific model you want to use. I'll use Sonnet 4.6, and I'll hit assign. It takes a couple of seconds to fire it up, and then it will have a screen which says view session. View session is basically we can see what exactly the agent is doing, and how we can we can read through the each steps which agent has taken. This gives us a more context and more understanding of what is being done, how this alert is being fixed. So you can see that assigning has been selected. I'll just refresh the page. Yeah, I'll come to this later. Let's come back to scenario A. You remember scenario A was like a very basic bump of a request package. It has already created a pull request. I will go ahead and open this pull request. So this is a very simple bump. It's this is Dependabot security update PR. I mean, if Dependabot security update is enabled in your repo, it will automatically create this PR. We are bumping the request from 2.28.2 to 2.33.0, and I can see the request has upgraded. Sorry, the request package has been bumped. The CI has passed. There's no there's no conflict, and I'll just go ahead and merge this. What will happen is in a couple of minutes, all the alerts which is related to the alert count will reduce, because all the alerts which is related to that particular PR that will get closed. Okay, it will take a couple of minutes. Now I'm coming back to scenario B. In scenario B, we tried Dependabot security update, and it pumped the light LLM from 1.0.3 to 1.83.0. Let me go ahead and open this pull request. As I described earlier, you can see the CI test has failed for this, because this particular when we are pumping light LLM from this version to 1.8.3, it's using um, Pydantic version v2, and this is failing. And this is exactly where we need AI coding agent. So this has failed. Now what we do is we go back and assign this alert, which we have already done to a AI coding agent. So let me quickly go back to the pull request. I will go back to the alert. We saw that CI has failed for this. Let's start and view the session. This is where the AI coding agent is doing its work. Okay, so you can see that it is setting up the environment. What it is doing, initially it installed all the MCP servers, like GitHub MCP server, Playwright, and some agents firewall, whatever the setup environment you have, it will install all those setup. It basically takes some time. Or let me refresh this. Okay, if I go ahead and click on the pull request, what happens? Somehow that view session is not displaying as of now, but I can see that it has already created the pull request. We can see there is no CI or CI test failing. I will try to go and click on the view session again later, but let's see what it has done. And again, any PR which is created by AI coding agent would be a draft PR. We as a human have to review it before merging it. I think it's still working on it, so it will take some time. I will go and view the session again. Yeah, in the meantime, the scenario A, like we closed one pull request, if you remember, which was the request which bumped from 2.28.2 to 2.33.0. And because of that, if you see, the vulnerability count has reduced. Earlier it was 20. Now, because of the merging of that particular PR4, vulnerability has been closed. So I'll go ahead and the scenario is complete. So this is a very simple uh, use case where we don't want to use an AI coding agent. That would be an overkill. We will just use Dependabot security update for Dependabot alerts. For the scenario B, I am still waiting. Claude is still working. So, so what I'm gonna do is it will take some time. So what I'm gonna do is I have already created this particular pull request just before the demo, so that if something goes wrong, I mean nothing is going wrong here. It is taking some time, but I'll show you exactly what the view session looks like. This is the same repo, but or like a test repo of that demo, a backup of that demo. This is the PR which Claude had created. I did that yesterday, and let me go and see the view session. So what happens is, like, as soon as the alert was assigned, it installs like GitHub MCP servers, and then what it does is, like, it calls semantic issue search. Basically, it is querying about the severity, checking who's the owner of the repository, the name of the repo. Then what it does is, like, it reads the file path, like the requirement.txt on this particular file. What are the requirements? And it reads all the repo basically, and then it reads the Python files to understand how light LLM is being used. Now, what it does is, like, it tries to understand the context, what's happening, and you can see, like, it is able to find out, like, what's the issue, what package is required, how we can fix it. It also figures out, like, the tests are failing due to the network. I mean, sorry, this is not this is the right message. It's trying to understand, like, what is failing, how we need to fix it, what in the code is failing. And if you go down, it is trying to it has found out like the conflicts, and it runs a couple of batch command trying to understand and doing some operations, and then it find out the issues, like what the exact issue is. The issue is like light LLM requires 1.444.8, uh, but the requirement has a scenario. Then it verifies all the installed version, everything has been passing, and it creates a summary. The summary is like it has successfully resolved this particular vulnerability by upgrading light LLM from 1.0.3 to 1.44.8. 8. It also describes what changes has been made. If you can see, like step 4 is very important, where it is changing the pydantic version v2 syntax in our code. And then it also doing some kind of a reachability assessment, though this vulnerability is not reachable, but it says like we need to make the changes for the future. uh, I'll go ahead and open the PR, and these are changes which it has made in app.py, where the tests were failing, so it now the test should pass. The changes made in the app.py, the actual changes, and then it is upgrading the dependencies. And if I go back to the main page, you can see the CI has passed and it is waiting for our approval. I'll go ahead at the review. I'll wait for the CI test to pass. And this is exactly which I was trying to showcase here. But somewhere like, the Claude is stuck right now. So I had this backup. So you can see that CI test has passed, and I can just go ahead and merge this pull request. And if we wait for a couple of minutes, I'll come back to this later. We'll see like all the vulnerabilities which were affected by upgrading the light LLM that will get closed. So this was one demo where like, I just do a recap where I showed scenario A, where we just need a simple Dependabot security update PR just to like, bump to fix the severity. Scenario B, where the AI coding agent was required, we had a CI test failure. Dependabot was not able to solve it. The CI run was failing, and we assigned it to AI coding agent, and it was able to like, fix that particular issue. Cool. Now let's go to another example where this is a repo where I have a simple app which is app.rb. I'm using a get. I'm reading a request into a doc, and I'm doing a pass. What it is doing is uh, using a JSON gem, and then I'm also using another gem which is Dependabot common. But this gem has a constraint where uh, the constraint is like JSON cannot be greater than 2.19. So for the vulnerability to get fixed, we have to upgrade JSON from 218 to 219. But because of Dependabot common has a constraint, the Dependabot security update PR is not able to like fix this vulnerability. So we have to assign this to a coding AI coding agent. So again, we'll go to the vulnerabilities tab. We'll see depend. This is the first alert which we will take. This time, again, I'll create a Dependabot security update PR. It will show me like it's not able to update it because of the constraint. But at the same time, I'll assign this to an agent, and I'll pick a different agent as of now. I'll use Codex. Okay, let me select auto. Something is not working here. I will. Okay, I have assigned. Okay, I was getting a wrong message that it is assignment is failed, but you can see like I have assigned three agents to it. So I'll wait for a second and see like how it proceed. But as I showed you, like Dependabot cannot update this station because there is a constraint here, and even if I try again, like it's not gonna help. So what? Uh, I'll wait for the session to run, and I'll see like the code AI coding agent will help in fixing it. In the meantime, when I'm waiting for this particular demo, I'll switch back to the previous one. I'll see like if this has no, it's still in the working. There would be like some issues. So yeah, I'll just go ahead and close this one because I just wanted to see like the scenario B which I had actually triggered live. Like what's the progress here? I'm sorry, I have to look into this. What's the issue here? But in an ideal situation, what will happen is as soon as agent is assigned, what happens is like the agent figures out that this particular Dependabot common is not reachable. It's like it is not being used anywhere in the code. So it basically does a kind of a reachability, and it removes this. It upgrades the version, and the PR is good to go to be merged. I apologize. There is some issue which I was not able to demonstrate this, but yeah, this is exactly what happens. When you do it with the AI coding agent. I'll switch back to the presentation now. So we need to know when to use what, and this decision framework will help. Like for as we've seen in the demo, for simple version bumps, we just use Dependabot security updates PR. They are instant, they work, and they have been doing this for years. Don't overcomplicate it. But when you hit up breaking API changes or a compromised package that needs a downgrade or a complex multi-dependency update, that's where you assign an AI agent. And one critical thing, always review agent output. AI generated fixes can be incomplete, can miss edge cases, or can introduce new issues. The agent opens a draft PR, you review before merging it. Let me make this actionable for you. The first prereq is you need a GitHub code security and a Copilot plan that includes coding agent access. This feature is available on github.com right now. The second, make sure Dependabot is enabled in our org or in the repo. Third, open any Dependabot alert, click assign to agent, select Copilot, Claude, or Codex. It's that simple. Fourth, review the draft PR the agent creates, verify test cases, merge when ready. Let me close by zooming out on where this is all heading, because the feature we demonstrated today is really just the beginning of much bigger shift. There are a couple of cards. I'll go quickly one by one. The first one, Frontier AI model find vulnerability at scale. 2 weeks ago, Anthropic announced Claude Mythos preview. This model has already discovered thousands of zero-day vulnerabilities in every major operating system and every major web browser. Not hypothetical findings, real and exploitable flaws. Over 99% have not been patched yet. What makes this different is sophistication. Mythos chains three, four, sometimes five vulnerabilities together into working exploits. In one cases, it wrote a browser exploit that escaped both the renderer and OS sandbox by changing four vulnerabilities. Card 2, Project Glasswing. Anthropic chose not to release Mythos publicly. Instead, they launched Project Glasswing, giving defensive access to about 40 organizations, including Apple, AWS, Google, Microsoft, JP Morgan Chase, and the Linux Foundation. The idea is simple: give defenders a head start, find and fix the flaws before similar capabilities reaches attackers. Card 3, the patching gap becomes crucial. Here is the uncomfortable reality: AI can now discover vulnerabilities faster than human teams can patch them. This is not a future concern. The US Treasury held emergency calls with bank CEOs about this. The Bank of England intensified AI risk testing. German banks consulted authorities. The gap between when a flaw is found and when it gets fixed used to be a backlog problem. Now it is a major security risk, especially for organizations running legacy systems. Card 4 is AI agent moves from fixing to finding. The feature we show today, assigning dependable alert to AI coding agent, is step 1. The agent fixes a known problem, but the next step is obvious. Agents that do not wait for an advisory, they proactively scan your code base, identify unknown vulnerabilities, remediate them before they ever become an alert. Full loop automation from detection through resolution without a human needing to triage each one. And the last one, Dependabot evolves into security orchestrator. This is the one where I want to spend a moment on because I get this a lot. Does Mythos make Dependabot obsolete? The answer is the opposite. Dependabot becomes more crucial than ever. Think of this way: Mythos is a MRI scan, a MRI machine that finds the tumor. Dependabot is the surgeon, the nurse, the operating room, and the follow-up care plan. You need both. When the volume of incoming advisory explodes from hundreds to thousands, someone needs to figure out which of your 500 dependencies are actually affected, whether your code even call the vulnerable path, what the right fix version is, and whether the fix will break your build. That orchestration layer is what Dependabot does, and it becomes exponentially very more valuable at scale. The evolution path looks like this. Today, Dependabot detects known vulnerabilities and open version bumps PRs. Near term, it becomes the intelligent router. It ingests flood of AI discover vulnerabilities, run reachability analysis to filter noise. In the future, auto routes complex cases to AI agent and only surfaces what actually matters to the developers. Further out, it evolves into a full supply chain orchestrator that proactively scans first party code, verifies artifact provenance, check for compromised packages before they are installed, and manages the entire lifecycle from detection through remediation through verification. In the last, all of this to work, the practice around supply chain security needs to be evolved. Dependency verification, artifact assigning, SBOM generation, and continuous attestation are no longer nice to have. They become table stakes. The old culture of shipping fast and patching later simply cannot survive in the world where AI powered exploits every discovery runs at a machine speed. The feature we demonstrated today, assigning complex alert to AI agent, is the first real step in this direction. It shows that the tools are ready to start closing the gap, and every organization that manages dependencies, which is essential, every software team on the planet needs to be paying attention to the shift. The key takeaways from today's session: security alerts without actions and noise. With AI agent assignment, we are closing the gap between detection and remediation of complex cases. Sorry, Dependbot handles the simple updates automatically. AI agents handle the complex cases that used to sit in backlogs, and the human stays in the loop for the review of AI generated fix. To learn more about Dependbot, scan this QR code. This will basically take you to a documentation of Dependbot and all its features. Thank you all for joining today. I would love to take your questions now. Drop them in chat or unmute if you like to ask live.
Hey, Ankit, it's Anna. Just checking in. Everybody in the chat, if you have any questions, now is the time to drop them. We currently don't have any questions in the chat, so if you have any frequently asked questions that you'd like to address, please go ahead and we can wait for our chat to catch up.
Awesome. So I have a couple of questions. Does the AI agent have access to my private code? The answer is the agent operates within the same permission model as the GitHub features. It can see your repository code to analyze dependencies and proposes fixes. The second frequently asked question is, can I use this with GitHub Enterprise Server? Right now, this feature is currently available on github.com. Check GitHub documentation for the latest availability. Third question is like, how accurate are the AI fixes? I mean, it varies. Simple cases are quite reliable. Complex cases need careful review. That's why everything is a draft PR. You always review before merging. Now, one question I get pretty frequently is like, how is this different from the Dependabot security update PR? And which I have explained in the slides and in the demo as well, that Dependabot security update PR uses rule-based version bumps. AI agents can reason about the breaking changes, rewrite code, and handle scenarios like malware-based downgrades that rules can't cover. Yeah, that's all from my side.
Awesome. We haven't had any other questions come through.
Okay.
For anybody who's watching on demand, we do have Ankit's LinkedIn linked in the description for our YouTube and LinkedIn videos. So feel free to reach out if you have any questions. All right, it looks like our chat is still pretty quiet. What do you think, Ankit? Should we wrap for the day?
Yeah, sure. Thanks,
Awesome.
everyone. Have a nice week.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.